I tried to highlight everything that's important in these instructions, which is basically the whole thing. So let's get started. You might realize that this is basically one gigantic slope problem because it's talking about the slope of the slopes, right? The rate of change of the average rates of change. So we're going to be doing a lot of stuff with slope. That's the old y2 minus y1 over x2 minus x1 equation. And what I'm going to do is focus for a moment on this consecutive equal length intervals phrase. And I'm going to construct this a little bit like a number line. Now bear with me. When it says equal length intervals, you can pick any intervals you want as long as they're equal length. I don't feel any need to prove myself or get fancy, so I'm just going to pick easy numbers like 1, 2, and 3. These are my x values, and they're equally spaced apart. So if those are my x values, I want to figure out the y value of each one. So I'm going to say f of x equals, here's my equation over here, 7x minus 2x squared. And I'll give you a quick example of what I'm doing, and then I'll speed through the rest of it. If I say f of 1, that's just plugging in 1 where all the x values are. So what I get for that when I do it is, let's see, we can do this in our head, right? This is 5. F of 1 equals 5. So I'm going to change my point on the number line from x equals 1 to a coordinate point, 1 comma 5. And then let's quickly zip through the next ones. F of 2 is going to be equal to 6, and f of 3 is going to be equal to 3. And you can run those numbers if you'd like. So let's label those on our number line here. We have 2 comma 6 as a coordinate point, and 3 comma 3 as a coordinate point. Now, let's get about doing those average rates of change. In other words, the slope of each of these sections. So in my first section, let me use a different color here so we can kind of keep track of what's going on. I'm going to use light blue for this. So my slope of this one, let's say section 1 to 2 slope, is going to be equal to, take the y values, 6 minus 5, and divide them by the x values, 2 minus 1. And the result is 1. That's our slope of that section. Now, let me change over to green ink. We're going to do the next section right here. This is going to be section 2 to 3, and that slope is going to be equal to the y values subtracted. So that's 3 minus 6 divided by the x values subtracted, which is 3 minus 2. And so in that case, I get, well, let's see, that's negative 3. So those are my two average rates of change. And now the question is, what's the rate of change of those particular slopes? No problem. We're going to make a rate of change equation, and watch what I'm going to put in it. I'm going to put the second slope. Let me write that equation down again, just so you see what's going on here. We're going to say rate of change of rates equals rate 2 minus rate 1, all divided by the distance between those rates. And that's a weird way to phrase it, but we'll use that number line again to wrap this up. So rate 2 we found was equal to negative 3, right? That was my second number. And rate 1, that was the first calculation we did, that was equal to 1. So I'm going to say negative 3 minus 1. Now, what's the distance between the rates? That is an odd way to phrase it. But if you look back at our number line, where were those average rates centered, so to speak? The first average rate was centered equally between x equals 1 and x equals 2. So we can think of that as being x equals 1.5. And the second rate was centered, by the same reasoning, around x equals 2.5. So how far apart were those rates? Not far, basically just 2.5 minus 1.5. What's the end result of this? If you crunch that into a calculator, it's not going to be too bad. You get negative 4. So that is our rate of change of the average rates of change. Now, if you notice, I picked some intervals that really helped me out a bit. These intervals were separated by nice numbers like x equals plus 1, then plus 1 more. And it made the math kind of simple. You could have, if you wanted, picked intervals that were further apart. Like you could have picked the x values 0, 2, and 4. The math would have worked out perfectly the same as long as you follow the same method here.